Hello and welcome to my circuit video. I am going to be making a transistor AND gate circuit, and I chose to make a transistor AND gate because I feel like it's very relevant in modern society, as it's used in basically all of modern technology, like computers, TVs, smartphones, radios, and more. Okay, now I'm just going to give you guys a brief explanation on how the transistor AND gate circuit works. So it consists of two transistors, and each one of those transistors obviously has a gate. And I'm just going to explain this graph real quick. So if both the gates are closed, the output is 0, so the LED will not turn on. If one of the gates are open, let's say gate B, the output is still going to be 0, because in a transistor AND gate, both of the gates need to be open for it to work. So if input A, if gate A is open and gate B is closed, the output is also 0, so the LED won't turn on. And the LED will only turn on if both input A and B, so both gate A and B, are open. That is the only time that the LED will shine and that there is current in the output. Here is my design for my circuit. Okay, I've now made a prototype of my circuit based off of my design that I made on this piece of paper. And to get it to work, oops, I should just first connect this back. To get it to work, I should just have to put in these two white wires to open the gate. Put them into the resistor. And as you can see, the light does not turn on, which means there has to be some type of issue, so maybe an issue in the contact. Oh, there you can see it just worked. As you can see, it does work, but it's slightly glitching, which means that the contact is not 100% good, but the prototype does seem to work, which means there's not a problem with the design. Okay, now that my prototype is working, I'm going to test out these buttons and see how they work using this multimeter. And then I'm going to draw another design and find out where I should place these buttons and just experiment a bit overall. Okay, now I'm going to be testing the button and its resistance to see how it works. So first, I'm going to test the resistance without pressing the button down. And as you can see, the multimeter shows a 1, which means there's no current flowing through and that the resistance is very high. And now, when I'm going to try pressing the button down, the multimeter shows 0, which means there's basically no resistance and that there's going to flow current through it, which is very cool. Okay, since there's so little room for the buttons to fit, I'm just going to redo the whole thing according to this new design that I made, and that's supposed to fit everything correctly, including the buttons. To get some inspiration for my new sketch, I looked at different videos on the internet, and I found this video from Ice-Matronics very helpful. I didn't fully copy his circuit design, but it helped me get an idea of how I should make my own. Here is my new and finalized sketch. Here is a video of me just adding some components into my circuit. No, it's working. Okay, now I've finished making the new prototype according to this new design that I made. And yeah, so basically the light should turn on when I press down both buttons, but not when I only press down one of them. And let's put it to the test. Good, doesn't turn on when I press the blue. It does turn on when I press the red button, which is a problem. And it does turn on when I press both buttons. So I'm going to have to troubleshoot this and find a solution. Okay, I've now fixed the issue. So as you can see, when I only press the blue button, it doesn't turn on. Only the red, it doesn't turn on. When I press both, it does turn on. And what I did was, I changed this resistor and the light from being in a series, so in the same row placed after each other, to being in the same hole parallel to each other. And so basically before, there always comes a bit of current when you press down one of these buttons. There always leaks a bit of current. And that current then turned on the light because they were placed after each other, the light and the resistor. and all the light got all the current. But now when they're parallel in the same hole, the light and resistor share the current that comes, and therefore there's not enough current from only pressing one button to turn on the light. While when you open both gates and press both buttons, there comes enough current to turn on the light, and therefore it works. Now I'm just going to play some videos of me soldering. Okay, while you guys watch me solder, I'm just going to explain a bit about the uses in society that transistors and logic gates have. So as I mentioned earlier, they're used in basically all of modern day technology. So computers, phones, TVs, radios, GPUs, CPUs, motherboards, all those are PC components. And all those things have helped society move forward, but these transistors and logic gates do also come with downsides. And one of those is the large amount of electronic waste that is produced when they're thrown away. So like old ones, when you dispose them, it produces a lot of electronic waste. Okay, I've now finished soldering and finished my whole circuit as well. So as you can see, it works. Pressed on the blue one, pressed on the red. Doesn't work because you need to open both gates, not only one, since it's a transistor AND gate. Press both. Light turns on. Here's the front, and here is the back. So yeah, thank you for watching. Sources will be in the description.